Welcome back to Summarize Science. Today, we're looking at how researchers are making robots smarter and faster by teaching them to focus on what's important. You know how when you're looking for your keys, you don't stare at every single object in the room? You scan for things that look like keys. Well, many advanced robots don't do that. They process the entire visual scene, including the background, walls, and other irrelevant clutter. This makes them slow, expensive to train, and often less accurate. But a new framework called SemanticVLA is changing that. It's designed to give robots a more human-like ability to understand instructions and visually focus only on what matters for the task. The core idea is called semantic sparsification, which is a fancy way of saying it intelligently ignores junk information. Using a text command like, "Put the alphabet soup in the basket," the system first identifies the key objects. It then creates a focused, compact understanding of the scene by combining what the objects are with where they are. This allows the robot to build a much cleaner mental map of its task, ignoring everything else. So, does it work? In simulations, the results are dramatic. On a standard set of robotic challenges, SemanticVLA achieved a top-ranked success rate of 97.7%. That's a huge 21% improvement over the previous leading model. And it's not just more accurate, it's incredibly efficient. The researchers found it reduces training costs by a factor of 3 and is almost 3 times faster during operation. This is because it's processing only a tiny fraction of the visual data it sees. Of course, simulations are one thing, but the real world is the ultimate test. Here we see SemanticVLA successfully completing complex, multi-step tasks like opening a drawer to place an object inside, and even folding a t-shirt. In these real-world tests, it outperformed the next best model by over 22 percentage points, which is a massive leap in performance. So, to recap, the researchers created a system that allows robots to filter out visual noise based on human instructions. This makes them significantly more accurate, much faster, and cheaper to train. It's a huge step toward making helper robots more practical and reliable. What does this mean for the future? This kind of efficiency could accelerate the development of assistive robots in homes, factories, and hospitals. Imagine a robot that can quickly and reliably tidy up a room or assist with complex assembly, all without needing massive computing power. It's a fascinating look at how teaching AI to focus brings us closer to the capable, intelligent robots of the future. That's all for this episode of Summarize Science. Thanks for watching.